Hello, very good evening, guys. Welcome to Resultant. After a long time, we are meeting. So, before starting the session, please do let me know whether my audio and video all good. Very good evening, very good evening. All right. So, how's your gate preparations going on? All good? Good evening, Sayyed. Good evening. Very few days left, right? In this last few days, I will recommend you try to just revise your concepts, and whenever you're getting time, just attend practice sessions so that you can boost up your confidence, because I know you are at very good level, you have prepared a lot. Now you have to just give your final touch by just revising the concepts and try to solve some questions so that you are not lagging behind in the race. Okay, good evening, Shravant. Good evening, very good evening. So after a very long time, now I'll be frequently seeing you on YouTube channel. Okay, because gate examinations are must very important now for all the mechanical engineers. So I think you should be giving your best. Good evening. All right. Into marks are not coming. Good evening, shares. Good evening. Uh, Tom, I will recommend you whatever you have studied, try to stick to that. Okay, I won't prefer or recommend you to take up any topic in tone which you are not comfortable with. Let us suppose there are 6 topics which you are comfortable with. Try to revise that 6 topics, more than sufficient. Okay, your target should be above 80, 85 plus, and definitely you can able to score even if you are skipping 2, 3 topics from tone. No problem. At this point of time, I will personally recommend you try to confine to whatever you have studied to that only. Okay, clear, Sayed? So let's begin so that we can have a discussion. It will be a long session, and I want you guys to just take a pen on paper so that we can solve a good number of questions right now. Fine. And I hope so. No need to have any introduction. You might be knowing me for the past few years. And you can connect with me if any new students are joining with us. You can connect with me on my Telegram channel, that is Mechanical by Sooraj. Right. And this is the complete practice session. There are some changes in the schedule. Right. I'm taking HMT right now. Tomorrow I'll be taking industrial. Then on Sunday I'll be taking uh, engineering mechanics. Right. Fine. I think tomorrow, yesterday I think production 1 was taken by Dheeraj sir. So today I'm going to take HMT. Then tomorrow I'll be taking industrial. Then I think production 2, and likewise will be completing everything. Okay, because we promised you will be coming up with good number of questions, and I hope so every day you are able to attend 8 o'clock the timing, 8 to 9, 9:30. Maximum 1.5 hours will be discussing the question, and that too gate level or slightly more than that of gate level, right? So shall we begin? Yes, guys. And before starting, please do let me know if you're having any problem or difficulty being faced while doing the preparation. We can just sort it out while going the session. Okay, fine, perfect. So let's begin and let's talk about the first question. Are you guys ready? Please do let me know. Yes. And one more important thing, just be calm and do not be confused, because it is having a normal perception. Whenever the exam date is nearer, you are forgetting many things. So better what you can do is, if you are able to understand what you are forgetting, you just at the end of the day, before going to sleep, 1 hour, try to take up the notes which you have written. Just go through, just roughly go through that, so that you are able to recall. Okay, right, very less number of times every day before sleeping, just go through the notes which you have prepared. Just go through, just we can say a summarized view or a formula notes. One day a new subject, and this way you will be able to revise, able to give. Okay, fine. So let's go with the first question. Before going with this was our rank up course, and definitely we are coming with more the students which are joining for 2026. We are definitely gonna help you on our channel, on consultant channel. Our faculties are there. Apart from this, Vikas sir has also connected with us. Sonu sir also joined. So our mechanical team is still strong. All the old faces, but the new platform. Okay, chalo, let's go with the first question on the screen. A classroom that normally contains 40 people is to be air conditioned using window air conditioned units, 10 kilowatt cooling capacity. A person at rest may be assumed to dissipate heat at a rate of 1440 kilojoule per hour. There are 10 light bulbs in a room, each having a rating of 300 watt, right? And the rate of heat transfer to the classroom through the walls and the window estimated to be 40,000 kilojoule per hour. They're asking you how many number of window air conditioning units need to be required. Good evening, Shishti. Question is how many number of air conditioning units are to be required. So basically, see, we are using 10 kilowatt cooling capacity. That means one AC will be able to cool, having a cooling capacity of 10 kilowatt. First of all, you need to identify what is the net requirement, how much heat will be dissipated in a room. 40 people are there, right? And each person is able to emit 1440 kilojoule per hour. Convert it to seconds because we have to convert it to kilowatt. There are 10 light bulbs and each having a rating of 300 watt. That means 3000 watt will be for 10 bulbs, 10 into 300. And if I say the rate of heat transfer to the classroom, the walls and window estimated to be, this is also given, this is the rate of heat transfer. So they're asking you number of air conditioning sets required in order to cool or maintain at 21 degrees Celsius. Okay, try this one quickly. Question is easy, not a difficult one. First of all, you try to identify what is the net amount of heat that is being transferred to the surrounding. Okay, so it will be net heat will be because of the people, right? We will be having the net heat because of bulb, and we'll be having net heat through, I think, conduction. Yeah, conduction. Okay, there are 40 people and each people is dissipating 1440. So we can say 40. Right, the next option A. Okay, 14400 into how many percent are there? 40 divided by 3600. Why? Because we are calculating in per second, right? In watt only, kilowatt. Plus bulb, each bulb is dissipating 300 watt. So 300 into 10. And next one is much 40,000 divided by 3. Please make sure you are taking up the calculator so that option A. Very good. This is everything in kilojoule per second. Everything is given in kilojoule. This will be divided. Option A. Shravan then Srishti is getting option A. How much you are getting? Somewhere around, calculator. Somewhere around 30.11 kilowatt. 30.11 kilowatt, right? So, and we have seen one AC is having cooling capacity of 10 kilowatt. Fine, one AC having a cooling capacity of 10 kilowatt, and we are need to required to cool this much amount of heat. So yes, perfect. Okay, so if I'm taking n AC, we are having n into 10, right? So number of AC will be, number of air conditioning required will be total heat divided by 10, that is 3.01, something 3.01, option A. Okay, option A, 3.01 number of, that means approximately 3 ACs will be required in order to fulfill the net requirement to maintain a constant temperature of 21 degrees Celsius, right? Okay, very good, Shares, very good, son. Shravan, Shristi, perfect. Sayyed, done. See, I told you we'll be taking questions level which is slightly more than that of gate. You won't be getting more than this level. Okay, in every session I'll try to take not PYQ but the question which are slightly more than that of gate, so that you are able to get that level of confidence. Okay, next question on the screen. Done? Very good, very good. There are two thermocouples who measure a temperature of 50 degrees Celsius and 40 degrees Celsius in a steel casing at a distance of 10 mm, 20. Okay, so basically there is a steel casing and we're having two thermocouples somewhere around here. One is having a distance of, let's say this is the reference line from where you are having 10, the same reference line we're having 20 mm along a hypothetical normal to the surface. This is that hypothetical line. Steel having thermal conductivity of 15 kilowatt per meter Kelvin. If airflow rate of the surface of a thick steel casing and the temperature is 100 degrees, what will be a convection? Okay, they're asking you what is the convective heat transfer coefficient. What is the convective heat transfer coefficient? H value. Simple, just we can go with the your energy conservation. What is the net heat conducted? That will be equal to net heat convected. Net heat conducted will be equal to net heat convected. So first of all, we need to see, and they have given the temperatures also. This is 50 degrees Celsius and this is 40 degrees Celsius. Okay, the distance between these two will be 20 minus 10 is 10. Right, so Ka delta T by L is equal to Ha delta T. Surrounding temperature is 100 degrees Celsius. Quickly solve it. Then NAT problem, approximately round off to the nearest integer. Just give me the value, round off to the nearest integer and tell me what's the final answer that you are getting. $375. Okay. When else? 60, 300. Nearest integer. Shravant and Atma is getting different. Range is very huge difference from other students also. Sayyed, yes, shares, 60. See, we have to use Fourier's law of heat transfer. Ka delta T by L, right, is equal to Ha delta T. That's it. K into A into delta T by L. See, if you want to maintain, see, whatever heat it's being conducted, that same heat to be convected to the surrounding, right? Then only we'll be able to maintain the rate of heat flow. Let us suppose, because air will be coming, if you're not dissipating the heat to the surrounding, then the heat will be accumulated and gradually the temperature is going to rise at the thermocouple. We have to release the heat at the same rate so that we are able to maintain. Clear? Ha delta T, that 2, yes, T ambient minus T mean. Okay, T mean will be how much? 50 plus 40 by 2, that is 45 degrees Celsius. Okay, K value is 15, A value get cancelled out, delta T is 50 minus 40 divided by thickness is 10 into 10 to the power minus 3. H value we need to calculate, this is 100 minus 40. Okay, tell me what's the nearest value. I think now you'll be getting the answer. Into 10 272, somewhere around 272.7, somewhere around you'll be getting 272.72 watt per meter per Kelvin. So nearest value will be 272 to 273. Okay. Final answer that you will be placing for integer, this is 272 to 273. 272 to 273. Oh, 7. Done. 272 to 273 will be the final correct answer. If you want, you can see in NAT problem. Make sure you are reading the instructions carefully. Sometimes they're asking you till 1 decimal. It will be definitely gonna be there. Decimal will be there. But if that decimal is not being shown, you have to read the question. Are they asking to the nearest integer or the decimal value up to 1 decimal? That's the reason I'm doing this kind of problem, because if you, this is a very small mistake that you might commit in the exam. Like t mean, normally we take it as 40 or 50, you'll be getting a wrong value and you will land up with a negative mark. Won't be able to fetch the marks from these kind of questions. The reason why we are doing this kind of session is you should be identifying some small mistake. That's it. Major mistake already have rectified. Long procedure you might be for the past 1 or 2 months you are practicing lot many questions. At the end we are just removing this small mistakes. Okay, so 272 is the final correct answer. Next question. Don't worry, I'll be sharing this PDF on my channel also, right, so that you can download for future reference. But I think so after this session you won't be requiring this PDF. Okay, next problem. Yes, Sugamana. Okay. Next, a cylinder of radius RO, length L, thermal conductivity K is immersed in a fluid having convection heat coefficient H and unknown temperature T infinity at a certain instant of temperature. So they have given some function of temperature. T is equal to A plus R square. So they're asking you what is the rate of heat transfer rate. Very easy question. Very easy question, guys. It's a very easy problem. Try to solve it and tell me the answer. A, B, C or D. Arithro, your preparation is all good now? Preparation is all good? Make sure you, this time I need single digit rank from you. Okay, or at least less than 50. Right? IR less than 50. I want you from this 2025 gate. Chalo. A, B, C or D. E, C, E, and next C and D. Different options. Okay, they're asking you cylinder hai, ye hai. Okay, Fourier's law. Q is equal to minus K del T by, because it's going in radial direction, del T by del R. Let's calculate del T by del R. Del T by del R will be 2R. Differentiate करते हैं. Let us differentiate this equation. Differentiate के बाद you will be getting this one, right? Getting this one. Differentiation. Let's place it over here. We're getting minus K into area will be 2 pi R naught, क्योंकि length is L, this is 2 pi R naught into L to 2 R. We have to calculate T naught. R naught आ जाएगा आपका minus 4 pi K R naught square into option C. Option C is the correct answer. Okay. Option C is the final correct. Done. ऑप्शन सी इज डन गाइस, हो गया? कोई डाउट, एनी डाउट, एनी प्रॉब्लम, डिफिकल्टी? नहीं होना चाहिए, ये सब बहुत इजी क्वेश्चन है. डोंट वरी इफ यू आर कमिटेड द मिस्टेक. आई होप यू आर अंडरस्टूड व्हाट मिस्टेक यू हैव डन. देखो, माय मेन ऑब्जेक्टिव ऑफ कंडक्टिंग दिस एग्जामिनेशन हॉल में, यू शुड नॉट बी हैविंग एनी प्रॉब्लम इन दिस चैप्टर, इन दिस सब्जेक्ट. ई ट्रांसफर का कोई भी क्वेश्चन आएगा, यू शुड बी एबल टू डू इट. दैट इज द थिंग विच आई वांट फ्रॉम यू. ओके, चलो next. Covered with an insulation of 2 mm thickness, and the conductivity of electrical conductor is 385 and insulation is 0.7. The convection coefficient at the insulation surface is 10 watt per meter square Kelvin for half a day and 40 watt per meter square Kelvin for other half of the day. Which critical value of radius of insulation should be used in order to cover the conductor? चलिए ट्राई कीजिए. 10 mm diameter. Let us draw the diagram. We're having radius is 5 mm. Insulation thickness is 2 mm. We have given 2 mm. बिल्कुल बिल्कुल सुब्रतो. थर्मल कंडक्टिविटी के इसका तो जरूरत नहीं है. वी won't be requiring this one. This is required. K of insulator. Sir, 7 watt per meter Kelvin. What is happening is they have given the two values of H. दो values of H दे रखा है. Two values of H is being given. So you have to calculate what will be the, which thickness of insulation will be, what critical radius of insulation we consider. K by H, simple. Let us calculate both critical radius, R1 or RC1, that is K by H1. पर ये निकाल के देखते हैं. और RC2, that is K by H2. K value is 0.07. H1 is 10. This is around 7 mm. And if I try to take 0.07 by 40, 1.75 mm. Fine. Now tell me what should be the final answer. What should be the critical radius that should be used? So A नहीं हो सकता, B. There are two options, either C or D. Tell me the final value. Either C or D. Either C or D. 1.75. Sure. I'm using 1.7 to 7 mm पे we are 7 mm will be getting a drop in heat transfer. See, remember one thing, all the electrical appliances should be used in region number 1. आपको याद होगा the graph. This is your RC, heat transfer Q, and this is your outer radius. Okay, this is region number 1, this is region number 2. Remember one very simple thumb rule, all the electrical appliances must be located in the region number 1, और जो भी आपका refrigeration system होते हैं should always be used in region number 2. Let us suppose if we are using critical radius as 1.75, So already we are having 7 mm. तो ये तो region number 2 पे हो गया. Are you able to visualize? If I'm using 1.75, so at 7 mm the heat transfer is gonna decrease. So what will happen? Heat dissipation decreases. The wire won't be able to dissipate heat to the surrounding, and the wire will be melted down. The chances of cutoff might be happening. Okay, and definitely that should not be happening. So electrical appliances should always be used in region number 1. ये आपको मैंने बताया था पहले भी. So option D is correct. हमेशा we try to take that value which should be able to cover the maximum range. देखो 1.75 mm लेने से what is the problem? We are able to take the values which are either less than or equal to 1.75. But if I'm taking 7 mm, I'm able to take the range of values of outer radius from 0 to 7 mm. Right? So definitely I should always opt for that range which is able to accumulate more variations in the radius. Okay, so option D 7 mm is the correct answer. देखो A and B is not the correct answer, obviously, because not the range. There are two possible values, 1.75 and 7. Okay, let us suppose if you are selecting, let us take an example. If you are taking the critical radius to be 1.75 mm. Okay, let us suppose. So basically you are at 1.75 and you are at a outer radius of how much? 7 mm. 7 mm is this one. 7 mm is the second range. So basically you are decreasing the rate of heat transfer by adding more insulation. So we are not in a comfortable situation. But if I'm taking, let us suppose, my critical radius as 7 mm, okay, the wire is having a 5 mm. Try to take, the wire is having a radius of 5 mm. If you add insulation, you are basically decreasing the heat transfer, right? If you are taking 1.75, if you add insulation, it will be decreasing the heat transfer because you are in region number 2. Here, fine. So definitely won't be opting for 1.75. 1.7 के case में you are already in region number 2. Added insulation will be decreasing the heat transfer. But if you are taking 7 mm, 5 mm is somewhere around here. You can have 2 mm additional thickness of insulation so that your heat transfer rate is going to increase. Okay, done. Clear? Now let's next question. Wait for the next one. Done. Understood, Syed and Shravan. I hope so that doubt is being clarified. Okay, fine. Next. NET problem. The options were there. Heat generated uniformly at a rate of 10 to the power 5. 10 to the power 5 watt per meter cube. Okay. In a large 3 mm thickness stainless steel, K value is given. Both sides of the plate are exposed to an environment of 30. So we can directly use this formulation. Both side is 30 degree. T infinity 30 degree. And the center line, the maximum temperature, this parabolic surface temperature T, surface temperature Ts. From here we'll be having Q convection. Both sides will be having Q. Use the direct formulas. I hope so by this point of time your formulas must be by heart. Okay, the formulation is T is equal to minus 2 dot by 4 2K x. ठीक है, तो TS equal to अब यहाँ पे one thing you have to make sure is we are taking the total length equal to 2L. That means 2L is equal to remember this. So L will be equal to 1.5. Okay. So they're asking difference between the highest and the lowest temperature of the plate. That means they're asking T0 minus Ts. This value they're asking. So we can use T0 minus Ts is simply Q dot L square by 2K. Okay. L value is 1.5 centimeter. 1.5 centimeter. Solve it. So T naught minus Ts, Q dot is somewhere around T naught minus S equal to Q dot is 5 over 5 into L square. L is 1.5, that is 1.5 into 10 power minus 2 whole square divided by 2K. K value is okay. Tell me the value somewhere around. How much is the temperature difference? Maximum to the minimum temperature difference is. Jaldi, quickly. Calculator should be, everyone should be having calculator. 3.72. Perfect. Kelvin or degree Celsius? What should I write? Kelvin or degree Celsius? Pravant, Syed, Shrishti, Arithro, Negi, Subrato, Kelvin or degree Celsius? Tell me the value. Let us suppose if you are saying Kelvin, can you tell me the answer? Degree Celsius. See, this is temperature difference. This is temperature difference. So even if they're asking Kelvin or degree Celsius, doesn't matter. You can write in Kelvin or degree Celsius, both are same. So this is the temperature difference. Right? Okay, very good, very good. Chalo, next. Next. Consider a long cylinder of radius 4 centimeter. Thermal conductivity is given. Heat is generated in the cylinder uniformly at a rate of Q generated is given. 248.38. Hey bhai, Arithro, degree Celsius or Kelvin doesn't matter. We'll be having same thing because it's a temperature difference. Right? Ravant and Sayed, just I've already in the comment section also. It doesn't matter. Whenever you are talking about temperature difference. Okay, fine. Okay, so they're asking you that they're asking heat flux. Heat flux के लिए you have to calculate del T by del R. Okay, calculate the value of del T by del R. That's it. They're asking you what is the value of Q minus K del T by del R, that too at R equal to R naught. This value they're asking you. So given you a hint, option C. Okay, differentiate karo, that's it. Differentiate to differentiate over here only by del R T. Okay, very good. Q naught where Q R Arnold's getting not fine. Now we can calculate heat flux minus K del T R at R. So okay, del T by del R आपको dot of 2 dot dot कितना 30. अच्छा, this is centimeter cube, so 10 power 6. 2 into R naught is 4. सेंटीमीटर में ही पूछ लास्ट इन 2 into R naught 4, so 8 into 35. 8 into 35 is 280 watt per centimeter. 280 watt per centimeter. हाँ, ऑप्शन वेरी गुड. ऑप्शन सी. ठीक है, परफेक्ट, वेरी गुड, वेरी गुड. ऑप्शन सी. ओके, perfect, very good, Danish. Very old students are joining. Next question on the screen. This is a question from Finn's topic. ठीक है, Finn's topic. One end of a long sad. Whenever they're using this word, too long, that means we are talking about infinitely long. Okay, by long. आपको you should be able to recall all the formulas. Same diameter, but different materials is attached to the base. So let us take this as base. Whose temperature is some base temperature not. We are having a material A. Having a material B. Different materials. Then we, I think, base temperature is 100 degrees Celsius. Surface exposed to an ambient air of 20 degree. Okay, it is observed that the temperature of the rod were equal at a position of 0.15 and this one. So these are the points where both are having the same temperature. Okay. Thermal conductivity of A is this one. What is the thermal conductivity of B? Very easy question. Very easy question. Quickly. Very, very easy question. So they are saying that, let's say at this point temperature is T, having a distance of same temperature is observed somewhere around. So what is the formulation? Formulation is quite simple. T minus T infinity upon T base temperature minus T is equal to e to the power minus m into x. बस equate करना है. Just you have to equate. That's it. So we can equate e to the power minus m1 x1 is equal to e to the power minus m2 x2 because LHS will be same. ये वाला जो LHS that will be same for both the case. ठीक है, so we can use m1 1 is equal to m2 x2. What's the formula of m? Under root of h k a. Right now, same ambient, so p h will be same. I think diameter is also same. Diameter is also same. Diameter same on p on area. This is 1 p h by k2 into a root of this into x2. Everything get cancelled out. So x1 by root k1 is equal to x2 by root. So x1 कितना है? I'm taking a as 1, so this is 0.15. Root of k1 is 70. 0.075. k2 value is somewhere around. Solve it and tell me a value watt per meter. Watt per meter. 17.5 option. 17.5 watt per meter Kelvin. Very good, Sayyid. 17.5 watt per meter Kelvin is the correct. Okay, done. 40 minutes has been passed and we are not jaldi ho gaya. We are almost covered the halfway of the session. 17.5 watt per meter Kelvin, and it is quite obvious that the material which is having your less thermal conductivity, heat won't be able to propagate to the longer distance. If you're having a high thermal conductivity, heat will be propagating to the larger distance. और यहाँ पे आपको देखने को it is quite obvious that Ka will be more than that of Kb. चलो next. Next question quickly, then we are halfway of the today. Two fin surface, long fin identical means diameter is same except that convecting heat transfer coefficient of the first is twice, so H1 is twice that of the second one. What statement below is accurate for efficiency and effectiveness of the first fin surface related to the second? Very easy, solve it. First fin surface with the second one. I hope you are able to see the options. Infinitely long, so efficiency formula is 1 upon m into L, right? And only one thing is variable, that is H. Only one thing is changing, that is H. Except everything, except H, everything is same. Aapka diameter, length, K, everything is same. Okay, only we are changing with the thermal this one convective heat transfer coefficient, that is surrounding. Okay, so we know that efficiency is equal to 1 upon m into L, and m value is root of P H by K. So efficiency is inversely proportional to root H. That means a material which is having high value of H will be having low efficiency. And also we know that effectiveness is 1 upon root of H by Pk. Effectiveness is also inversely proportional to root H. अब बता सकते हैं क्या होगा आंसर? A, B, C और D. A, B, C or D? Tell me quickly. Srikanth, Aritro, Shreyas, Syed, Shravant, Srishti. A, B, C or D? Both are inversible. That means a material which is having high value of K, low. Read the options. They're asking you the statement below is accurate for efficiency for first fin relative to the second. First fin related to the second. First fin relative to the second. Quickly. नहीं सृष्टि, गलत, wrong answer. Danish, options पढ़ो भाई, गलती मत करो. These kind of mistakes should not be committing. They are asking you first relative to the second. That means you have to tell me first is having higher efficiency or lower efficiency. First is having higher effectiveness or lower effectiveness. That's it. Base you are comparing. Okay. Comparing the first one with respect to two. Both lower. Option D. Option D is the correct answer. Why you are saying option A? They are saying that what statement below is accurate for the efficient effectiveness for the first surface relative to the second. First surface having more H value, so low effectiveness, low efficiency. मैं बहुत बढ़िया गीत, बहुत बढ़िया. Option D is correct. Very good. Okay, done. Can we proceed to the next one? ठीक है, clear? हाँ, obviously दोनों काम है ना, क्योंकि first surface का H value is more. So definitely whose H value is more, its effectiveness and efficiency has to be. Okay, option D is correct. Now before going to the next question, I hope so you all have connected or downloaded our app, where some free PDFs is also there, some are also there, right? And those who are planning for 25 and 26, So we are just coming up with the live classes already. For 25 also we have given what we are promised. Definitely for your juniors or the students who are seeing our sessions for the first or second time, they can just feel free to connect with us. Dheeraj sir number is there on the screen. Okay, everything is available. Now let's go to the our app. So here is our resultant mechanical app. So all the mechanical students, you are downloading this app. ठीक है, आपको कुछ नहीं करना, प्ले स्टोर में जाना है. You have to write resultant mechanical preparation app. From there you can download, install, and you can get access to all the features on our app. Okay, fine. Chalo, next question. And those who are new to our sessions, this is the number, Dheeraj sir's personal number. You can contact him at the earliest stage. Our heat capacity, okay, it is same. बढ़िया, all good ना? तो नहीं है, nothing is. Balance मतलब balance means CH is equal to CC. That means m dot Cp for hot fluid is equal to m dot Cp for the cold fluid. CH is equal to CC. बताइए, without even having any second thought, you should be getting the answer A, B, C or D. Balance heat exchanger, by this point of time you should be able to answer to this. This is counter flow heat exchanger. It will be, temperature profile will be something like this: parallel and linear and parallel. Okay, hot fluid, cold fluid. Option B. Option B. Clear? No doubt, right? Option B. Very good. Shravan, C nahi, B. Okay. Next. NTU is maximum for same heat transfer coefficient and same fluid. NTU, okay, in which case the NTU maximum, they are saying H is same and same fluid. That means the property is same. What is the formula of NTU? NTU is equal to UA by C minimum. To the formulation. Now we know that delta Tm of counter flow is the highest. Then you can say delta Tm of cross flow, then delta Tm of parallel flow. This we know, right? This sequence I hope so you know. Counter का सबसे ज़्यादा होता है, then we are having shell and tube. Write that also. T shell and tube, cross flow, we are having parallel flow. So whose this will be there? So area will be least of counter, then shell, then cross, then highest will be for parallel flow. Okay, and NTU is additive proportional to area, so parallel flow will be having this. Maximum NTU will be there for counter flow. कैसे? A option. Who is saying A is the correct answer? Counter flow will always be a compact heat exchanger. If you're having all the properties same, if the inlet and exit temperature, if the properties are same, heat transfer coefficient also same, then counter compared to parallel flow will be a compressed one. That means a compact size. Compact size means area is less and NTU is directly proportional to area. Okay. Shell and tube, shell and tube. Shell and tube only say is coming under shell and tube only. See, if some phase change is occurring, then all the values are having same. Counter, shell, cross flow, parallel flow, all will be same. So in that case, doesn't matter, all will be having same NTU. But if you are having multi-pass or anything, that comes under shell and tube. Okay, definitely that is not that effective as compared to counter flow. Chalo, next. But Apart from this, there are many parameters, but we are taking a same ground, same reference level. Okay, next. A counterflow concentric tube heat exchanger logarithmic temperature difference is, okay, they have directly given you delta Tm. Delta Tm is 56 degrees Celsius. Hot fluid is 0.1. So m dot H is 0.1 kg per second. And 110 degrees Celsius is cooled by, so this is your hot inlet, 110 degrees Celsius. Cold inlet is 25 degrees Celsius. Mass flow rate of the cold fluid is 0.2 kg per second. Hot fluid CpH is 4.2 kilojoule per kg Kelvin, and C is equal to 2.1 kilojoule per kg Kelvin. What is the exit temperature of cold? Chalo, try this quickly. What is the exit temperature of the cold fluid? First of all, identify which fluid is having the minimum heat capacity. Dot C. Let's do one thing. Let's see CPC and CPH. What is this? M dot C CPC कितना है? Calculate this one. Dot C 2 C is 4.42. H is dot H CPH. Oh, this is the same counterflow. Now you tell me the answer. Now you tell me the answer. You should not be taking more than a minute to solve this question. This is a question from the balance heat exchanger. This is the question from balance heat exchanger. Quickly tell me the value. C option. Okay, 54. Someone is going with option C. So I think this is an easy one. So this is a balance one. So we can directly draw linear and parallel. Just now I told you hot inlet is 110. Cold inlet is 25. Delta Tm is given as how much? 56. Oh, so we can say TCO minus uh, 54. 54. We can write 110 delta Ti is equal to 110 minus O, and that is also equal to delta Tm, that is 56. Okay, so TCO will be equal to 110 minus 56, that is 54 degrees. Option 54 degrees Celsius. Okay. Heat exchangers say if they're asking you any question, you should be able to solve. Heat exchanger is a easy topic. Easy, slightly calculation must be there, but overall I would say that it's a scoring topic. Okay. Okay. Next question. Next question. Yes, quickly. Let's go with the next one. Then a cross flow. It's a question from cross flow. The question from cross flow heat exchanger. A cross flow heat exchanger is used to cool water having this, air is having this, water enters at 100 degrees Celsius at a rate of, पहले तो ये दिखाइए कि भाई this cool water. Okay. पहले तो बताइए. Okay, okay. Question is interesting. Tell me, is used to cool water with hot air. Which is cold fluid? Which is cold fluid? Tell me, air or water? Which is cold fluid, air or water? Quickly. Read the statement appropriately and tell me. Used to cool water. Cool water means they're basically trying to confuse you, but you should not be getting confused. Cold fluid is air and hot fluid is water. Okay, fine. Let's try to eliminate this. इसको हटा देते हैं. Having confusion. Okay. Now, heat exchanger. Water enters. Water enters. Water is hot fluid. So THI is 100. M dot H is 4. Four kg per second. Air enters at 20 and the mass fluid of the cold fluid is 9. Overall heat transfer coefficient, अरे भाई how many watt per meter square Kelvin. Effectiveness is also given 0.65. NTU is also given 1.5. What will be the heat transfer surface area? They are asking you the area. Yeah. Asking you the area. First of all, let's calculate which is having a minimum C value. Hot fluid or cold fluid? So CH dot H dot H कितना 4. Hot fluid is 418 equal to we can say C is our C minimum. Our got a conclusion that C is our C minimum. Okay, so something NTU is equal to U A by C minimum. NTU is equal to U into A by C minimum. That's it. NTU values they have given 1.5. U value they have given 260. Area value we need to calculate C minimum is 9. Tell me the value. 52.44. Very good, Sayyid. 44. 52.44. Done. Correct. Very good. Very good. Done. Please, then we have to start with radiation also. Here, 52.44. Same thing. Unmixed. Water side, basically they're asking the shell. Same thing. Because see, it's cross flow. In cold fluid is I think it should be only for slight confusion because the formulation for NTU is UA by C. Chalo, next. Now this kind of question, for the last 3-4 years, they are starting to ask question from the passes. They're saying 2 shell passes and 8 tube passes condenser. Condenser, phase change. Phase change. Okay. With 20 tubes in each pass is used to condense steam on the shell side. The cooling water enters at a rate of 2 kg per second. Water enters. If the rate of heat transfer area is given as 14 meter square and overall heat transfer coefficient is 800 watt per meter square Kelvin. Effectiveness they are asking. What's the value of effect? Cooling water है ना? Cooling water, condenser means steam, so hot fluid is, so we can write C minimum will be equal to m dot to C, because we are using water is having 4.18, so 2 into 4.18 or 4180. Six okay, fine. So NTU we can calculate now. NTU is equal to UA by C minimum, 100 40 3 or 3. Can you tell me what's the value of NTU? Somewhere a rough value of NTU. 3.014. 3.014. Please check. 3.01. So approximately we can take it as 3. Let's take approximately equal to 3 for easy calculation. Now, what is the formulation of NTU? This one, effectiveness. If there is a phase change, there is a direct formula. Phase change ke liye, what is the formula? 1 minus e to the power minus NTU. Calculate कीजिए 1 minus or minus. Answer is 95%, 0.95. 0.95. 0.95. Very good, Sayer. .95. Done. And very good, Arithro. Good, very good. Perfect. Next question. चलें आगे, next question. But before going to the next question, I want you guys to please let me know. अभी तक like तो नहीं, अभी तक कर दीजिए. To like the session, because one thing I would like from you is a like. Okay. चलो next problem on the screen. Okay, water is heated. Shravan. Yes. Effectiveness is less than 1 means definitely it is more effective. What's the formulation of effectiveness? Q actual by Q maximum. Q actual by Q maximum. And for heat exchanger, we always be getting somewhere closer to that. It is almost okay. Fine. Why we use this one? Array phase change. For phase change, we are having a direct formula 1 minus e to the power minus NTU. Remember? 1 minus e to the power minus NTU, right? Okay, perfect. Thank you guys. Doesn't matter, Arithro, it doesn't matter if it's a phase change. You can use a parallel flow, counter flow, cross flow, shell and tube, doesn't matter. You use anything. It's same for all the cases. Okay, fine. That is the reason we are just not going shell pass 8 tube, 20 tubes, doesn't matter. Okay, next. Water is heated from 25 to 60 by a steam condensing. Steam condensing, again a phase change. Okay. If water flow remains constant but the inlet temperature changes to 30 degrees Celsius, then they're asking you a simple question, the new outlet temperature. The new outlet temperature. Quickly. The new outlet temperature. Quick. Vector S formulation. Okay, let's do one thing. Vector S1 is equal to cold fluid to T2 minus I upon T minimum O THI minus TCI. This will be also will be having the temperature T minus 5 125. Now we are changing to a new temperature of cold outlet. We need to calculate code inlet is same. Use T minus 30 120. Hello, T value. Solve it. Tell me what's the value degree Celsius. The water flow remains same. We are not changing the heat exchanger. Only we are changing the inlet temperature. That means U A by C minimum, everything is same. The effectiveness is also same, because for a phase change, effectiveness is 1 minus e to the power minus NTU, and TU is U A by C minimum. If you are not changing the fluid, the U value is also same, A is also same, so and effectiveness will be same for both the cases. That's when we are equating. Okay, U is same, A is same, and C minimum is same. You can simply say we are just changing the temperature. Quickly solve it. Somewhere around up to 2 decimals can do, let me know. Into 63.25. 63.25 degrees Celsius. Perfect. Okay, quickly done. 63.25 degrees Celsius. Okay, clear. Next question. The next question on the screen. Now let's start some radiation problem. An opaque surface of area is considered to be diffuse. Absorptivity is given 0.43. Emissivity is also given 0.7. Surface is maintained at 500 Kelvin. Maintain 500 Kelvin, simultaneously exposed to the solar irradiation of 1500. What will be the radiosity? Very easy question. What will be the radiosity? Radiosity means the total radiation leaving or incident. The total radiation leaving the surface, right? You might have studied concepts. This is a surface, radiation, irradiation of G is coming. Some part will be reflected. Because of the temperature, we'll be having some emissions, right? So we can say the radiosity, that is J, is equal to rho times G plus E. And I think they have given 1 minus alpha to G emissivity. So 1 minus 0.43, G value is how much? 1500. Plus emissivity is 0.7 into E value sigma into power 4. 0.57 500 plus 7.6 power minus 500 power 4. Okay, solve it. Now I want how much, Syed? 33333 5.625. Okay, check everyone. I'll be writing the value which Syed has told me. 3 5 5 what per. Please check everyone. Are we getting the same value over here? 333 5.625 watt per meter. Yes, very good, Shrishti. So we got a confirmation from 2 students, and I think that is correct. 3335.6 watt per meter square is the total radiosity which is leaving. Done? Clear? Fine. Very good. Next question. Without a question from this one, shape factor, your this one questions from heat transfer is not completed. So let's try this one. Consider rectangular surfaces. Consider rectangular surfaces shown in figure. View factor is given F31, F321 plus 2, and what is F223. So this is surface, write it over here. This is surface 2, this is surface 1, and this is surface 3. So they have given you from 3 to 1 and 1 and 2. What is easy question? Easy question. Now can we say F3 to 1 plus 2 nothing but F3 to 1 plus F3 to 2. Now this value they are given as 0.32, this given as 0.27. So can we get the value of F32? Yes, quickly calculate F32. So 0.05, 0.05. If we got the value of F32, can we get the value of F23? Reciprocity theorem. Okay, now we can use reciprocity theorem. that is F23A2 is equal to F32A3. This we need to calculate. A2 value will be 1 into 3 same only. F3 A3 is also same. Both are having the same area. So F23 is 0.0. Ah, Arithro, why you're getting area is this one only, right? One. Have they given half the length? No, that dimension should be 7. That dimension should. This actually, that arrow is not appropriate. This is 1. Let me draw the dimensions over here. This dimension is 1 meter. Okay, see this one. 1 meter only, right? Unless and until if it is at 0.5, it should be mentioned midpoint or something like this, which is not being mentioned. Okay, we should not be assuming anything by default. Basically a correction in the diagram, it should be 1 meter. If it is 0.5 meter, then we can write 0.5 into 3. Okay, if they are giving you 0.5, then we can place it 0.5 into 3. No worries. Okay, let's do one thing. Let's try to take 0.5. Let me reframe this. So this it is, this dimension is given in the question. Okay, this is not, we are telling this dimension is given. This dimension is not there. Okay, fine. So now we can change some value over here. 0.5 into 3. Okay, if it is 0.5, now the value will be changing 0.025. Okay, clear? 0.025. .025. Okay, very good. Chalo. Done. Next. Okay, few questions left. Only few questions more. 1 or 2 questions. Next problem on the screen. For same initial condition, one can expect the laminar. Okay, convection question. Laminar thermal and momentum boundary to the flat plate to have same thickness when the Prandtl number of the fluid is. Question is, for the same initial condition, one can expect the laminar thermal and the momentum boundary layers on a flat plate to have same thickness when Prandtl number of the following fluid is how much? That means they are saying that TBL is equal to HBL. Hydrodynamic boundary layer and thermal boundary layer both are same. When this is possible? When this is possible, we know one formula. Prandtl to the power minus 1 by 3 equal to delta T by delta. Delta T is nothing but the thermal boundary layer and delta is the hydrodynamic boundary. This is your delta. So both will be same. If Prandtl number is equal to 1, then delta is equal to delta T. Possible. Option C. Option C. Very good. Okay, done. Clear? Perfect. One last question, then we are free to go. Consider a hot boiled egg in spacecraft that is filled with air at atmospheric pressure at all times, disregarding any radiation effect. Will the egg cool faster or slower when the spacecraft is in space instead of on the ground? Okay, where the heat loss will be more, on the ground, that means on the earth's surface, or outside the earth's surface, that is in outer space where there is no gravitation? A, B, C or D? Option A, option B, option C or option D? Quickly. Will the egg will cool faster or slower when the spacecraft is in space instead of the ground? Quickly. Option A, faster. No difference. Slower. Srishti is going with all, no difference. The option D is not possible. A, B or C? Quickly, this is the last question. I think so. This is the last question. Quickly tell me, then we'll be winding up the session. C. Okay, tell me one thing. Because they are saying that disregarding any radiation effect. So radiation is not present. So only mode of heat transfer that will be there is will be due to free convection, because air is not flowing. And in free convection, we know that Nusselt number is equal to C times Grashof into Prandtl to the power m, right? And Grashof number is this one, E beta delta T L cube by mu square. Okay. Now, if you try to compare this value with the ground, so ground will be having more G. If I try to compare ground, the G value is more, because rest everything is same. And an outer space, the G value is less. So can we say in the outer space, your G value less means the egg will cool slower in outer space? Option C. Because you see that Nusselt number is equal to C to Prandtl to the power m, right? So we can say in outer space, the G value will be less. If G value is less, Grashof number is less. If Grashof number is less, that means your Nusselt number will be less. If Nusselt number is less, means H is less. H is less means heat transfer will be low. Means slow cooling. So, okay. So options कम होता है? Very very less. I'm not saying we are going to we can say out of gravitational pull. Very less gravitational pull we are having. Very less. We can take 0, but 0 में then we won't be having any convection heat transfer. Convection आपको almost होगा. Very very less. You can take it as very. Okay, fine. Done. Faster will be at the ground. They are asking in the space. Done. So these are the all set of questions that we are having for today's session. Tomorrow at 8 p.m. we'll be discussing questions from industrial engineering. Right? All the questions we'll try to cover, all the chapters we'll try to take for tomorrow's session. Shravant, okay, no, I've already informed. I thought it was rectified. Okay, no problem. Shravant, I'll, sir. Okay, if possible, can you tell me the date? Can you tell me the date class so that I can data I can easily fetch personally. Fine. So tomorrow at 8 p.m. This is tomorrow. Tomorrow at 8 p.m. we'll be having discussion of industrial engineering, right? And all the students, those who are planning for 26, are launching a new batch for gate aspirants, right? A 1 year course where Chandra sir, Sonu sir, me, Veera sir, even Vikas sir will also be joining. Complete team to live as well as recorded class. Okay, fine. Feeling hungry? Me too. That's the reason I wind up the session. And please follow us. There is an Instagram channel and Facebook channel. वहाँ पर भी you can follow us and happy to help. Okay. Thank you. Shravant, September. About September. Oh, you are saying last year. That means you are saying in Byju's. Byju's, the person, the backend team, no one is there right now. The complete dead end, right? So classes, that is not, even the person who was handling the recorded classes, everything, not, our entire team is not there. Byju's Gate is not there, so I no possibility of having those sessions. Okay, zero possibility. Right? But if you are having any doubt or difficulty, I'll be happy to help you out. Right? Chalo, Arithro. Okay, fine. So thank you guys. We'll meet tomorrow. Let's not deviate from the path. Tomorrow 8 p.m. Industrial. Hearing पे मिलते हैं tomorrow. Do not forget to subscribe to our channel. We'll be having this kind of useful session tomorrow also. चलो भाई कोई नहीं. Just stick to your path. Try to be. Do not deviate. All this everything and energy. Okay. Fine. Thank you guys. Bye bye. Take care. Stay safe and enjoy your preparations with our team that is resultant. Bye bye. Take care.